Hi everybody, welcome to AGAA-MATH. This is Rakesh. Now let us learn the basic classes of trigonometric ratios. Before going to learn about the trigonometric ratios, here how the sides are named in a right angle triangle. Because basically to understand the trigonometric ratios and to study about all the remaining, we have to know about the right angle triangle and how to name the sides of in a right angle triangle. Let me take a right angle triangle here. Right, this is a right angle here. This symbol indicates a right angle here, and this is named the triangle A B C. As this is a right angle triangle, so the side opposite to 90 degrees. This is. Before you watch the video, like our channel, subscribe it and click on the bell icon for notifications. It's 90 degrees. The side opposite to 90 degrees, this is the side opposite to 90 degrees, is called hypotenuse. It is nothing but hypotenuse. Hypotenuse. So here the side AC is said to be the hypotenuse. Right? Now what about the sides AB and BC? Here these are the sides are named respective with the angle A and angle C. When I take an angle A here, that means angle BAC. Angle BAC. This is the angle BAC. So respective with angle BAC. Respective with the angle BAC. So BC is said to be what? Opposite side. Opposite side. And respective with the same, then what about AB is called? So AB is said to be the adjacent side. Is said to be the adjacent side. So this is said to be the AB is said to be the adjacent side respective with the angle A. If I take the angle B here, angle C, respective with angle C, that is BCA. So angle BCA respective with angle BCA, AB is said to be the opposite side. AB is said to be the opposite side. And next, if you see the BC, BC is said to be adjacent side. So we have three sides of a right angle triangle. One of them is hypotenuse, which is fixed here, and this is hypotenuse, which is fixed. Only the changes happens with the side AB or BC respective with the angles here, either A or C. So if you take angle A, then BC is the opposite side and AB is said to be the adjacent. Similarly, if you take the angle at C, so that we take AB as the opposite side and BC is the adjacent side, and this is fixed because the side opposite to 90 degrees, this is 90 degrees, it is fixed. So the side opposite to 90 degrees is said to be the hypotenuse. Now let us see how to let us have a practice. What are the opposite side, what is the adjacent side once again. Now if don't think that right angle triangle is always only in this shape, right? So this is indicates at 90 degrees, so it may be like this also. So here I take 90 degrees, and now I name this is PQR. PQR. So your angle Q is 90 degrees. Now respective with angle P. Respective with angle P, what is the opposite side? Children, can you? Yes? Yeah, now angle P, opposite side is QR. So opposite side is QR. Next, with respect to the angle P, then this is said to be the adjacent. So adjacent side, in short I write as ADJ, so that is adjacent is PQ. Then what about PR? PR is fixed, right? It is called hypotenuse. Hypotenuse. So that is PR. So these are the respective with angle P now. If I take the respective with angle R, respective with angle R, what is the opposite side? Anybody please? Yes, respective with angle R is PQ is said to be the opposite side. Then adjacent, we are not supposed to take hypotenuse because this is fixed, so that RQ or QR is said to be the adjacent side. And the next hypotenuse is said to be PR. PR is said to be the hypotenuse. So these are the sides of a right angle triangle where we have to remember, because in trigonometry when we use the ratios, what is the ratios and all this we are going to study in the next class, but you have to know what is the opposite side and what is the adjacent, what is the hypotenuse respect with the angles. So hypotenuse is fixed. This hypotenuse is fixed. No change. So change happens only respect with angles, either P or R. Similarly here whatever you take. Okay, so remember one thing, this indicates, when it represents like this indicates a right angle triangle. Right children, and one more thing you have to know in right angle triangle, how to find the lengths of the sides if any two sides are given. Here this is a right angle triangle children, right? If the length of this side is 4 units and the length of this side is 3 units, this is 3 units and this is 4 units, then how to find the length of the hypotenuse? According to the Pythagoras theorem, we have that sum of the squares of two sides, sum of the squares of two sides is equals to square of hypotenuse. Square of hypotenuse. This is said to be the Pythagoras theorem. So according to this, sum of the squares of two sides, so that it means AB square plus BC square is equals to AC square. It means what? 4 square plus BC is 3 square, it's equals to AC square. We don't know what is AC, the length of AC. So 4 square is nothing but 16 plus 3 square is nothing but 9, and it is AC square. So 16 plus 9 is 25. When I transfer this square to this towards the LHS, so it is under root of 25 is equals to AC, so that AC is equals to, you get 5 units. So the length of this hypotenuse is 5 units. So even you have to know this thing also, how to find the length of the other side when any two sides are given, that is sum of the squares of squares of the two sides, sum of the squares of the two sides is equals to square of hypotenuse. So it is nothing that AB square plus BC square is equals to AC square for this triangle. That is AB square plus BC square is equals to AC square for this triangle. So this is nothing but Pythagoras theorem. Let us see one more example now. Let us see here one more. Here the length of this right angle in this right angle triangle MNO, the length of MN is 5 units and MO is 13 units. Here you have to find the length of the unit, like length of this side is NO, how many units it is. So just before we have already learned about the according to the Pythagoras theorem, sum of the squares of two sides, that is MN square plus NO square is equals to MO square, right? So MN is 5 units, that means it is 5 square plus NO we don't know, so let it be NO square is equals to MO is 13 units, so that is 13 square. So in this case 5 square is nothing but 25 plus NO square, let it be, as we have to find it now, 13 square is 169. So NO square is equals to 169 minus 25, because 25 transfer this side, it is minus. So NO square is equals to 144. So NO is equals to under root 144. So what is the length, the square root of NO? That is 12. So that here NO is 12 units. So in this way we can find the length of the other sides when any two sides are given. This is what today's class. Thank you for watching.